Dear students, welcome to today's class. Today in the limits concept, so I will start the class with proving the theorem limit extends to a x power n minus a power n by x minus a is equal to n into a to the power of n minus 1. Understand? So the proof is in general method, majority of the students know. Generally we will start the proof like this. How? So let us take x power n minus a power n is equal to, we will write the formula as x minus a into x power n minus 1 plus a into x to the power of n minus 2 plus a square into x power n minus 3 plus so on a to the power of n minus 1. Afterwards we will take x minus a to left hand side and we will apply the limit extends to a on both sides and we will get the solution. It is a very easy method. It is very easy method comparatively which I am going to teach. Now here I am going to approach in a different way, that is binomial expansion. Okay now. So I will use the binomial expansion, the formula binomial expansion. Using binomial expansion we are going to prove it. So it is one method. It is one of the method to prove this theorem. So we know the binomial expansion, this is a 1 plus x whole power n is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square n into n minus 1 into n minus 2 by 3 factorial x cube plus so on, where modulus of x is less than 1. Since here x value lies between minus 1 and plus 1, when x value lies between minus and plus 1, we can avoid these higher powers. So we can eliminate these higher powers of x. That means x square, x cube, they still will become very close to 0. That's why. So we will take this binomial as 1 plus x whole power n is equal to 1 plus nx. So using this concept, we are going to prove the theorem. Okay now. So now what is here? Let you take x is equal to a plus h. X is equal to a plus h. Substitute in the given equation. So left hand side. Left hand side is equal to, what is left hand side? Limit extends to a x power n minus a power n by x minus a. Now see here, as x value tends to a, as x value approaches to a, as x value, see here x is equal to a plus h, as x value approaches to a, that means if you bring a this side, x minus a is equal to h, x minus a is equal to h, x minus a is equal to h, as x value approaches to a, h value approaches to 0, that means limit h tends to 0. In place of x, substitute a plus h whole power n minus a power n by, in place of x, a plus h minus a plus h minus a. Okay now. Any more constants we can cancel? Yes, we can cancel here. Minus a plus a we can cancel. In the numerator, so can I take a power n common outside? So this is a limit h tends to 0, we can write it as a power n. If you take a power n, so this is equal to 1 plus h by a power n, h, this is whole power n minus a power n by h. Okay now. In the numerator, totally we can take a power n common outside. So this is equal to a power n, we can take common outside. Limit h tends to 0, 1 plus h by n whole power n by h. So this is equal to a power n into limit h tends to 0. Here we can apply 1 plus x whole power n is equal to 1 plus nx. Okay now, the higher powers of h by a. So h is here a very small quantity. Here h is a very infinitesimally small quantity. Okay. So this is equal to 1 plus nh by a by h. So 1 plus nh by a by h. Okay now. So when you are taking a power n common outside, here minus 1 will there, here also minus 1 will be there. So here a power n you are taking outside, there minus 1 will be there. So any more cancellations? Yes, we can cancel here. Plus a, plus 1, minus 1 we can cancel. H also we can cancel. So therefore, limit h tends to a, n by a is will there. N is a constant, a is also a constant. Therefore, n into a power n by a, n into a to the power of n minus 1. So n into a to the power of n minus 1. This is one approach to prove the theorem limit x tends to a, x power n minus a power n by x minus a is equal to n into a to the power of n minus 1. Okay now. So actually speaking, comparatively this method, so this is a very easy one. So this is easy one, and you can, everybody can understand this. But try to those who are wants to improve the subject knowledge. So this way also we can prove the theorem. Okay. So I hope that you understand this theorem. So basing on this, some problems are there. So let us solve the problem. Okay. Hi students, welcome to this problem. So basing on the theorem that we already learned, we have to solve this problem. So here limit x tends to 1, root x plus root x plus root x, 3 roots are there. So there root of 4 roots are there for x minus 4 by x minus 1. Then how to solve this problem? So कैसा solve कर सकते हैं इसके problem को देखो. So see here. So this is equal to limit x tends to 1. Root x means how much? X power 1 by 2. Root of root x, that means x power 1 by 4. That means x power 1 by 2 whole power 1 by 2, 1 by 4. So this is x power 1 by 8, x power 1 by 16 minus 4 by x minus 1. Okay, so that is the first thing we have to write. So now we here minus 4 is there. No, we will write the minus 4 as limit x tends to 1, x power 1 by 2 minus 1 plus x power 1 by 4 minus 1, x power 1 by 8 minus 1, x power 1 by 16 minus 1 whole divided by x minus 1, here x minus 1, here x minus 1, here x minus 1. Okay, right. So according to the properties of limits, we can apply the limit x tends to 1 each and every term in that algebraic expression. So now this will here 1 by 2 will be there. We can write down x power n minus a power n by x minus a is equal to n into x to the power of n minus 1. That is a 1 by 2 into 1 to the power of 1 by 2 minus 1, it is a 1. So here how much you will get? 1 by 4. Here 1 by 8. Here 1 by 16. LCM 16, here 8, here 4, here 2, here 1. So 8 plus 2, 10, 15 upon 16. So 15 upon 16 is the right answer. So here the first thing idea is you have to express this powers like this, and the second idea that we have to got is here minus 4 is there. No, minus 4 we can write it as a minus 1, minus 1, minus 1, minus 1. Therefore minus 4. And separate this x minus 1 to the base to each and every term, then it will become a known formula. Okay now. So I hope that you understand this solution. So let us move to next problem. Welcome to this problem. If limit x tends to 0, 4x minus 1 whole power 1 by 3 plus a plus bx upon x is equal to 1 upon 3, then we need to find out a value and b value. Okay. So this type of problems will be asked in any type of any competitive examinations. Let us see this problem, how to do this. Solution. Generally students what they will do, the first step what they will do, no, so x tends to 0 means they will start substituting 0. So here 0, so minus 1 whole power 1 by 3. So here also 0, so here also 0. So it is not getting 0 by 0 form. Why? Because we don't know a value. So therefore L'Hopital rule is not applicable here. Then how to proceed here? So we will do one thing here. So limit x tends to 0, 4x minus 1 whole power 1 by 3. 4x minus 1 whole power 1 by 3. Okay now. So this problem can be done using binomial expansion. So see here, first you take a minus common outside. This is a 1 minus 4x whole power 1 by 3 a plus bx whole divided by x is equal to 1 by 3. Okay, so just now we explained the binomial expansion of 1 plus x whole power n. So there we can avoid x and higher powers of x. So here we have to treat that here mod x is less than 1, it lies between -1 and +1 as x value approaches to 0. So as x value approaches to 0, therefore we can consider the interval -1 to 1. Okay, now right. So this is equal to limit x tends to 0 -1 into this is 1 minus 4x by 3. 1 minus 4x by 3. 1 plus nx. Here 1 minus nx. So here a plus bx upon x is equal to 1 by 3. Okay, now right. Let us rearrange the terms. So here the power is gone. Okay, happy. Now let us rearrange the terms. So this is a limit x tends to 0. Here a is -1 is there. A minus 1 minus into minus plus. So this is equal to 4 by 3 plus b into x by x is equal to 1 by 3. Okay, now minus into minus plus 4 by 3, here b is there, 4 by 3 plus b times x divided by x is equal to 1 by 3. So to limit exist, so the limit exists, here a minus 1 value should be equal to 0, therefore a is equal to 1 we got. A minus 1 by 3 minus should be equal to 0, therefore a is equal to 1. Now let us take this problem, remaining problem. So this is equal to 4 by 3 plus b into x by x is equal to 1 by 3. X will get cancelled. So therefore 4 by 3 plus b is equal to 1 by 3. B is equal to 1 by 3 minus 4 by 3. B is equal to, so here 1 by 3 minus 4 by 3, 1 minus 4 minus 3 by 3 minus 1. So b value is -1. Okay, so a value 1 and b value is -1. So I hope that you understand this solution. So let us move to next problem. Welcome to this problem. Evaluate limit x2 tends to infinity x cube into square root of x square plus square root of 1 plus x to the power of 4 minus x root. How much this value is there? So then if you here x tends to infinity, so you cannot substitute infinity in the given expression. The only thing everybody will get that idea is here -1 is there. So multiply the numerator and denominator with everybody will get that idea. X square plus root of 1 plus x to the power of 4 plus x root 2 into root of x square plus root of 1 plus x to the power of 4 plus x root 2. So everybody will get that idea. Okay, now. So in the numerator a plus b times a minus b. So the formula is limit x tends to infinity x cube into a plus b into a minus b, a square minus b square. So here x square plus root of 1 plus x to the power of 4 minus here x square, here 2x square. 2x square divided by, so here under root of x square plus root of 1 plus x power 4 plus x root 2. So any more cancellations or any more simplifications? So this is a limit x tends to infinity x cube into, so here what you will get root of 1 plus x to the power of 4 minus x square upon root of x square plus root of 1 plus x power 4 plus x root 2. Then what shall we do again? So again here minus is there, take a plus here. So that is equal to root of 1 plus x power 4 plus x square by root of 1 plus x power 4 plus x square. Understand this? Right. Again numerator a plus b into a minus b. So we will get this formula limit n tends to infinity x cube into, see here a plus b times a minus b, a square minus b square, 1 plus x power 4 minus x power 4 by these two quantities. So root of x square into root of 1 plus x power 4 plus x root 2 into root of 1 plus x power 4 plus x square. Okay. So any more cancellations? Clearly we can cancel plus x power 4 minus x power 4 we can cancel. See the numerator. So we will get the numerator. Limit x tends to infinity. So numerator we will get x cube by. Here see what can be taken common outside. In the first there are two factors are in the denominator. In the first two factors we can take x common outside. In the second factors we can take x square common outside. We can take x square common outside. So here we can take x common outside. Here x square, second factor x square common outside. X into x square, x cube will be there. X cube will be there. Understand this? So x cube will be there. Okay, so this is a very, very important step. So we will continue the solution. Welcome back. So we will continue the solution. Limit x tends to infinity. Here x cube upon. Here we can take x common outside. Here x square common outside. So total x cube will be there. So here how much we will get here? We are taking x square common outside. So here x to the power of 4 we will take common outside. X to the power of 4 means it will come x square outside. Again x square, x will come outside. So that means here 1 plus root of 1 by x power 4 plus 1 plus root 2 into. Here we have taking x to the power of 4 common outside. When it is coming out of the root, it is x square. So this is equal to root of 1 by x power 4 plus 1 plus 1. Understand this? So we know that as x tends to infinity, 1 by x to the power of 4 tends to 0. Here also 1 by x to the power of 4 tends to 0. As the denominator goes on increasing, total fraction value approaches to 0. Okay now. So in this place we will substitute 0. Here also substitute 0. So here x cube we can cancel since x is not equal to 0. Is x tends to infinity. Since x cannot be equal to 0, therefore we can cancel. So what is the final answer? This is a 1 by root of 1 plus, see here, root of 0 plus 1, 1, root 1, 1. So this is a root 1 plus root 2 here. So this is also root 1, 1 plus 1, 2. So this is equal to 1 by, so this is equal to 1 plus 1, 2, root 2 plus root 2, 2 root 2. 2 root 2 into 2. So this is equal to 1 by 4 root. So this is 1 by 4 root 2 will be the final answer. Okay. I hope that you understand this solution. Let us move to next problem. Welcome to this problem. Evaluate limit x tends to infinity 7x square plus 1 by 5x square minus 1 whole to the power of x to the power of 5 upon 1 minus x cube. Then how to solve this problem? Limit x tends to infinity by property. So we have the property that limit x tends to a f of x, if it is whole power, g of x is there. We can apply limit x tends to a f of x whole to the power of limit x tends to a g of x. Okay na? We can apply the limit for both base and power. Okay, we can apply. Okay, no problem. So here also I will find out. So limit x tends to infinity, this base, and limit x tends to infinity x to the power of 5 upon 1 minus x cube. See, carefully observe this problem. So majority of the students they will do they do mistake as x tends to infinity problems. Majority x tends to infinity problems. The majority of the students, they misunderstand the problem. Okay, so let us see this carefully, observe this problem. First I will find out the base. So this is a limit x tends to infinity 7x square plus 1 by 5x square minus 1. This is absolutely 7 by 5 value. We know the short trick. Here x square coefficient is 7. Here also x square coefficient is 5. Therefore 7 by 5. No problem. So everybody will do that. So the total problem lies here. What is the power? That means limit x tends to infinity x to the power of 5 by 1 minus. This is the, what is the value of this? This is very important. So if you know this problem, the solution is over. Okay, right. Here, let us divide the numerator and denominator with x cube. So this is equal to x square by 1 by x cube minus 1. Limit x tends to infinity x square upon 1 by x cube minus 1. So what we did? So we did dividing the numerator and denominator with the x cube. Now the problem is, as x tends to infinity, x square also tends to infinity, x square tends to infinity. So that means here numerator tends to infinity by denominator. See here 1 by x cube tends to 0, 1 by x cube tends to 0, 0 minus 1. So this is a minus 1, this is minus infinity. That's all. That is very, very important. So total this problem tends to minus infinity, tends to minus. So numerator as x tends to infinity, x square also tends to infinity. Okay, here 1 by x cube, this is a 0, 0 minus 1 minus 1. So 1 by x cube minus 1 tends to minus 1. So this is equal to minus infinity. Okay, now coming to the problem. So final problem, it is a base, and the power is minus infinity. Okay, so 7 by 5 whole to the power of minus infinity. This is 1 by 7 by 5 whole power infinity. So this is equal to 0. So as the denominator is tends to infinity, 7 by 5 whole to the power of infinity, the answer will be 0 is the correct answer for this. Okay, so very, very careful about this this problem here. Okay, so I hope that you understand this solution. Let us move to next problem. Welcome to this problem. Evaluate limit n tends to infinity cos of pi into root of n square plus n, where n belongs to z. N tends to infinity. Then how to do this problem? Okay. So generally students, what they will start doing, so they will take n square common outside. So n square, that means here 1 plus 1 by n. So here n square means n will come, n pi will come. As n tends to infinity, cos of n pi is equal to how much, like that they will start doing. So that's generally, so what the students will do, limit n tends to, not only students, everybody do like this. So this is, they will do start doing that, cos of pi. So n square plus n, they take the n square common outside, that means n into root of 1 plus 1 by n. So n square n. Okay, now right. So here actual modulus of n you have to write down, no problem, as n tends to plus infinity, positive infinity means modulus of n is equal to n only. Then as n tends to infinity, 1 by n tends to 0. So total this is a 1. So this is n tends to infinity, cos of infinity pi. Then how to do this problem? There the problem will become break. Then how to approach this problem? Okay, now let us see this, everybody. So first we will take common outside. So here 0. So root 1 plus 0, 1. So here n pi, here n tends to infinity, cos of n pi is how much? As n tends to infinity, cos of n pi is equal to how much? There break will come. Now let us see how to do this problem. So see here, limit n tends to infinity, we can write down cos of n pi minus pi into root of n square plus n. Can we write like this? Cos of n pi minus pi times root of n square plus n. Can we write down? So here, see here, if it is n is equal to 1, so this is equal to how much? Cos 180 minus theta. Cos 180 minus theta is equal to how much? Minus cos theta, but here plus cos theta. If it is a 2 is there, n is equal to 2, 2 pi, cos 2 pi minus theta, cos 2 pi minus theta means cos theta. Fourth quadrant, there plus here there. So depending upon the n value, sometimes you are getting plus, sometimes you are getting minus. That's why to avoid that, if I write down minus 1 whole power n, now the expression is perfect. If it is a n is equal to 1, cos pi minus theta minus cos theta, here 1 is there, no, minus will come, minus into minus plus will come. Okay, now if it is n is equal to 2 pi, so here 2 square positive, 2 pi minus theta, cos of 2 pi minus theta is cos theta only. Okay, now right. So very nice. So this is, take it outside, minus 1 whole power n, limit n tends to infinity. Okay, no problem, you have to, even though if you keep, no problem, as n tends to infinity, minus 1 whole to the power of n, you can keep, no problem here. As n tends to infinity means So here this n value is different from this n value. So try to understand this. Minus 1 whole power n, you can take it. Otherwise you can put m also. You can put m also, we can put, no problem. So otherwise you can keep, no problem. So limit n tends to infinity minus 1 whole power n. So this is a cos of, now you take n common outside. So you can take pi also common outside. If you take pi common outside, so this is equal to n minus root of n square plus n. If you take pi common outside, n minus root of n square plus 1. So multiply the numerator and denominator with n plus root of n square plus n, denominator n plus root of n square plus n. Okay, na? Right. So this is equal to limit n tends to infinity minus 1 whole power n cos of pi into, so here a plus b into a minus b, a square minus b square. So this is equal to n square. Here n square minus n square minus n divided by n plus root of n square plus n plus root of n square plus n. So here any more cancellations? So here you see here plus n square minus n square cancel. Cos of minus n pi, you can write down n pi, no problem. So this is equal to limit n tends to infinity minus n whole to the power of 1. Cos of this is n pi by, in the denominator take n common outside. If you take n common outside, n into 1 plus root of n square, you have to take common outside, 1 by n. Okay, now 1 by n. Okay, so here n will get cancelled. As n tends to infinity, here 1 by n tends to 0, 1 plus 0, 1, 1 plus 1, 2. So on the whole, you will get, so limit n tends to infinity minus 1 whole power n, limit n tends to infinity cos of pi by 2 you will get, cos of pi by 2 you will get. So cos of pi by 2 value is equal to 0, cos of pi by 2 value is equal to 0. So you will get here 0 into, definitely it cannot be, it can be 1. So you can take it as a 1. Limit n tends to infinity minus 1 whole power 1. So as n value goes on increasing, so first here put 1 and you put 2 and you put 3, you will put 4, you put 4, so on it approaches to 1. So on the whole you will get 0. So 0 is the correct answer. Okay. So I hope that you understand this solution. So let us move to next problem. Welcome to this concept. So we have very important expansions are there. So these expansions are useful. So to do the problems not only from limits, from trigonometry problems and differentiation problems, even in algebra also, some problems will be solved using these expansions. So these are very important expansions. Log of 1 plus x, log of 1 minus x, e power x, e power minus x, a power x, a power minus x also will come, sin x, cos x, tan x. This is a basic expansion that every student should learn, should know, should by heart. Okay, now, so see the first expansion, so log of 1 plus x. This is x minus x square by 2 plus x cube by 3, x power 4 by 4 plus x power 5 by 5. So on observe here the condition is minus 1 less than x less than or equal to 1. Understand here. Observe the here power, actually base 1 is there. Here 1, 2, 3, 4, 5 all bases are sequence order. In the x power 1 is there. X square, x cube, x power 4, x power 5 automatically plus minus is coming. So if it is a 1 plus x, alternate plus minus is coming. If it is a minus, total minus is coming. X power 1 by 1. 1, 2, 3, 4, 5. Minus, all minus we are getting. So try to understand here. Right. E power x expansion is a very famous. If you know e power x, you can write down e power minus x, you can write down a power x, you can write down a power minus x also. So e power x expansion is 1 plus x square by 2 factorial, x cube upon 3 factorial, x power 4 upon 4 factorial. So e power minus x means what? Wherever x is there, substitute minus x. Here if it is a minus x, if you substitute, this is plus x square. If you substitute minus x whole cube, minus x cube, so on will come. Okay now, so this is equal to e power minus x. Okay now, a power x. So here a power x means here. So x into log a to the base e. X square by 2 factorial into log a to the base e whole cube. Next term, x cube by 3 factorial into log a to the base e whole cube plus so on it will come. Understand? If it is a power minus x is there, no, here minus will come, here plus will come, here minus will come, here plus will come, alternate plus and minus. And sin x, cos x, tan x expansion. If it is a sin x, x minus x cube by 3 factorial plus x power 4 by 5 factorial, x power 7 by 7 factorial, all plus minus plus minus. This also plus minus plus minus. For tan only all positive will come. For sine odd numbers 3, 3, 5, 5, 7, 7. For cos even number 2 factorial 2, 4, 4 factorial 6, 6 factorial. Okay now? Now for tan x, x plus x cube by 3 plus 2 by 15 into x to the power of 5 plus so on, like that will come. So always by heart these expansions. Using these expansions we can solve some problem. Okay, let us see some problems based on these expansions. Welcome to this problem. Limit extends to 0 e power sin x minus of 1 plus sin x upon tan of sin x whole square. Then how to do this problem? So this type of problems definitely will be asked in your JEE mains examinations. Then how to do this problem? See here, e power x expansion we know. 1 plus, okay. Tan x expansion we know. Tan x expansion. That's why put sin x is equal to h. Put sin x is equal to h. Okay now? So this is equal to limit as x tends to 0, sin x is also tends to 0. Therefore, h is also tends to 0. H tends to 0. This is equal to e power h minus of 1 plus this is a h by. So this is equal to tan h whole square. Wherever sin x is there, I have substituted h. Now we will go for expansion. So this is equal to limit h tends to 0, e power x expansion 1 plus e power x expansion. This is a 1 plus x by 1 factorial x square by 2 factorial so on. E power h means 1 plus h by 1 factorial plus h square by 2 factorial so on. Okay now. So this is a 1 plus h will come. So this is equal to, so here tan h expansion. So tan h expansion is what? h plus h cube by 3 whole square. So now what will be, can be cancel anything? We can cancel anything. So here if you observe here, we can cancel here plus 1 minus 1 cancel, plus h minus h we can cancel. So there h square by 2 factorial so on it remains. So let us see here. So after cancellation this we will get here. So what we will get, a limit h tends to 0, h square by 2 factorial. So here we can take a h common outside. When you are taking h common outside means h square you will get. So h square you will get here 1 plus h square by 3. H square 3 means h tends to 0, 0 by 3, 0, 1 plus 0, 0. So h square cancel. 1 by 2 factorial means how much? 1 by 2. 1 by 2 factorial means 1 by 2. So 1 by 2 is the final answer. Okay now? So I hope that you enjoyed today's class. With some more problems, tomorrow's class I will come before you. So until then, all the best.